Hello everyone, meteorologist Hutch Johnson joining you live from the Valley News Live studios here in lovely and snowing Fargo, North Dakota. We have a live look, but class is beginning shortly, so as you log in, I'll just getting set up. Good to see you all getting ready and joining for our weather class today. Today's topic, as you can see on the screen, hail, chunks of ice from above. I'm looking forward to talking to you about how hail forms, what causes it to happen, and what we look for storms to produce hail, kind of what goes on inside the clouds. As you sign in, Alex from Moorhead is signed in. He's 11 years old. Thanks for signing in, Alex. Go ahead and give me a thumbs up and let me know where you're signing in from. Gavin is joining us from Oslo. Hi, Gavin. Island life, Gavin says. I believe it. There is a lot of water out there. Good luck to all of you up there in the Central and Northern Valley. Hey, Chase, good to see you, buddy. Glad you can join us again today. Today we're talking hail. I see sad faces and angry faces, but if you give me thumbs up and smiles, it makes Hutch feel a little better about what we got going on today. Hey, here's what we got going on today as we take a look at our sky cam. Here's Hutch. Just hanging out with you. Looking forward to class today. Hi, Elliot. Hi, Julian from West Fargo. Good to have you. And Kim from West Fargo as well. Good to have all of you. I'm going to just sit here and remind you that today I asked you to, if you have a chance to gather some frozen peas, maybe golf balls, things like that. Hutch is sitting here with his trusty old can of corn because at Hutch's house I ran out of peas. And I didn't want to stop by the grocery store. Can of corn will do just fine. So I got some corn for our experiment today. We'll do that a little bit later. Looking forward to it. All right. Again, I'm a meteorologist. I broadcast every night talking about the weather. It's a great job. It's a fun job, and I really enjoy doing it. But once in a while, I also get to talk to folks about why the weather does what it does. It's a lot of fun to do that as well. And for almost 20 years, I taught a college-level meteorology class in a lab to go along with it in Bismarck. Nathan, good to see you. I hope you're having a great day. Hi, Parker from Wahpeton. Good to have you joining us there from the Southern Valley. Okay, let's go ahead and get started with today's topic, shall we? We'll go ahead and get the computer fired up. I made a couple of graphics to help present the topic of hail today. So here we go. Hail happens. Alec, hi, good to see you, buddy. Hope you're doing very well. Scott, good to see you. Hope you're doing good. I want to give both of you guys a wave. Thanks a lot for joining us here on Valley News Live. Kyle in Fargo and Papa in Alabama joining us again in Alabama. Hey, let's talk hail. Thunderstorms. You see one on the screen in front of you. Thunderstorms are pretty amazing things. And we talked a little bit about thunderstorms earlier when we talked about our subject of lightning in the first week that we did class. Now, this thunderstorm that you see here, a couple of interesting points. Number one, thunderstorms form above the ground up at the cloud level as rising air, hot bubbles of warm air cool and condense and start to form a cloud. Now, as we go up from the ground on a hot summer day, like in Alabama now, where temperatures are a lot warmer than in Fargo, okay, those hot bubbles of air might be 80 degrees or warmer, okay, and they rise up through the atmosphere, and as they go up, the pressure drops and they get colder and colder. So up inside thunderstorms, as we learned when we talked about lightning, hey, Haas's from north of Valley City, good to have you on board. Hi, Rita. Good to have you on board as well. Love having you all here for class today. Make sure you, in the comment section below, tag a friend who you think might enjoy these classes, even if they live across the country. We keep these posted on the Valley News Live Facebook page, on Hutch's Facebook page. Do a search for Hutch VNL. You'll find me on there. And go ahead and give my page a like, too, if you like these. Hi, Chad from Minneapolis, Minnesota, and saw somebody from Bemidji fly by. Wendy, good to have you on board from Bemidji as well. Say hi to Babe the Blue Ox next time you're by downtown. Stephen, Minnesota, good to have Ryland with us. And hi to Haley from Valley City. Now, as our warm bubble of air rises in a thunderstorm, it cools, and the temperatures up at cloud level, as we talked about when we studied lightning, have to be below freezing. We have to have ice in the cloud to make thunder and to make a thunderstorm. Consequently, these storms can have a lot of ice in them with temperatures that get that cold. And we kind of need that as well to make hail and to make heavy rain and to electrify those thunderstorm clouds. Now, the next step is when we have a rising pocket of air, sometimes as the cloud is lifting those water-cooled droplets up through the sky and it gets colder up there, there's ice cubes, they start freezing and running into other water droplets and ice cubes. We form hailstones. This one appears to be about the size of a nickel. This person has a nickel in their hand, comparing it to the hailstone that fell at their location. Hi, Kelly. Good to have you on board. And Northeast Minneapolis. Good. Chad, I heard you guys had a 70-degree day there in Minneapolis. We in Fargo have not yet had 70 degrees, so we're a little jealous. All right. Now, what's the difference between that hailstone and this one? Do you see that? Cindy and Greenbush, do you see that? Good to have you on board. Doug, good to have you on board. What's the difference between the first picture of hail I showed you and this picture of hail I showed you? Okay? Well, that hailstone right here, this one is a lot more bigger. Okay? And a little note at the bottom here. If we can have a stronger updraft, then we're going to get bigger hail out of those thunderstorms. Okay? Hey, Kai and Kirk, good to have you from North Fargo. You wanted to be a meteorologist as a kid? Oh, that's awesome. And your uncle was one with the National Weather Service in Bismarck. That's very cool. What's the last name? Lystad. Okay. Well, I may or may not have worked with your uncle out there in Bismarck. Hi, Hutch from Derrick and Carrington. Good to have you on board. So if we have stronger updrafts, we can get bigger hail. So we have hail of all different sizes. And believe it or not, North Dakota is a great place to see different sized hail. Some places get a lot more hail than we get, but it's a lot of small hail because the atmosphere doesn't quite get as cold as it does over us. And we can form some stronger updrafts. So meteorologists, if we're going to forecast thunderstorms, we got to have the updrafts that we talked about. We have to be able to have them be strong enough to make tall clouds like thunderstorm clouds. And those thunderstorms have to reach up to cold, frozen temperatures up in the sky, and then they will electrify and make lightning and thunder. And then once they do that, we'll be good. Hi, Wendy. Do you have something?
From Renee, our A+ to you.
Oh, okay. Yes, absolutely.
There's some tips about
All right. We'll pass this along to my students here in class today. All right. Here is a look. If we have these thunderstorms forming, and we can find areas that have these stronger updrafts, we might be able to pinpoint where some stronger storms are possible, and we might be able to warn people ahead of time that big hail might fall from these storms. And that's what meteorologists continue to try to do by researching the atmosphere and trying to figure out how this stuff works. Now let's look inside the cloud a little bit, and this simplified graphic here shows our updraft blowing air upward. Okay? And we don't often think of air rising really fast, right? We don't think of air rising real fast. And we don't need really fast rising air to support cloud droplets. Have you ever walked through fog? If you've ever walked through fog, then you know what it's like to be inside a cloud. Okay, so if you're a pilot and you fly through an airplane through a cloud, those cloud droplets are extremely tiny. They're extremely small. If you've walked outside on a foggy day, you don't walk out with eyebrows that are dripping wet, soaking wet all the time, because those water droplets that make up the cloud are minuscule and very tiny. So those tiny droplets can be supported by just a little bit of rising air. We don't need really fast air to support the weight of a cloud. Kids ask me all the time when I go talk to their schools, they say, how do the clouds stay up in the sky? Aren't they heavy? Well, yes, water's very heavy. If you've ever carried a bucket of water, you know how heavy water can be. But cloud droplets are tiny. So it only takes a little bit of an updraft of air or rising air to support those tiny little cloud droplets. Now, as they grow and bump into each other inside the cloud, those cloud droplets get a little bigger. They double in size, triple in size, they get 10 times bigger, and then finally they're big enough to be a drizzle drop. A drizzle drop is about a 0.5 millimeter in diameter or less. That's tiny. It doesn't take a lot of upward rising air to support a millimeter droplet-sized piece of water or ice. As that drizzle drop doubles in size, it becomes raindrop-sized. Raindrops, they can be a little heavier, right? And because they're heavier, and if it's just a weak updraft, they'll be too heavy for that updraft to support, so the raindrops will fall out of the cloud, just like in Hutch's graphic. So I'm going to turn the camera back around to the computer here. Once these raindrops grow big enough and they get to be raindrop size, oftentimes, if we don't have a really strong updraft, they'll fall down out of the bottom of the cloud as rain, and that's how precipitation happens. The cloud droplets grow, they get bigger, and then they get too heavy for the updraft and they fall. Hi, Teresa from Waban. Good to have you on board. Glad to see all of you students on board today. I hope school's going good for you as well. Why don't you also leave in the note, I've never asked you guys this though, but I'd love looking through what your favorite subject is in school. So go ahead and in the comment section, type in what your favorite subject is. I'd love to hear it. Hello to Chad from Fargo, Colfax, Hillsboro with the relatives watching. Okay, so raindrops get big enough, they can fall from the cloud. But if the updraft is even stronger, it can support bigger and bigger raindrops, and it can support bigger and bigger chunks of ice. Now, we grow these raindrops inside the cloud bigger and bigger. And remember, our cloud is at freezing temperatures. So we can have liquid water that's rising up from the bottom of the cloud. Okay, and we can also have inside the cloud what's called super cold water drops. Super cold water drops are called supercooled water. That's right, Jill, it's science. That's awesome. I'm glad you like science. It was my most favoritist. I was a lot gooder at math and science than I was at grammar. Can you tell? Okay. All right. Hi, Teresa from Fisher. Good to have you on board from Polk County. Let's take a look here. Inside our cloud, if we have super cold water drop, what does that mean? That means we can have a liquid water drop in the cloud that's still liquid. It's still a liquid drop at temperatures to 40 below zero. Now, once it gets colder than 40 below zero, it's all ice in the cloud. There is no supercooled water liquid drops left. They can't remain liquid at temperatures below about 40 degrees below zero. But up to that temperature, we can have water that's freezing at temperature, but it's not frozen yet. And that's called the supercooled water droplet. Those suckers will freeze on anything on impact, kind of like freezing rain did in our experiment the other day when we sprayed our spatula that was metal and cold with water. Supercooled water drops freeze when they collide with another supercooled water drop. So if we get supercooled water drops that bump into each other, boom, they become a piece of ice or a small piece of hail. If that piece of ice is too big, okay, for the updraft to support, or it blows out of the updraft like here, it'll start falling out of the cloud. But sometimes they get drawn back up into the updraft and they grow again because they collide in with these supercooled water droplets again. And they'll grow again, and then they get out here and they're with the rest of the ice and they fall. And some of those drops that grew twice get caught up in the updraft again and again and again, and they kind of bounce through this cycle, okay? And that's how hailstones can grow bigger and bigger and bigger inside clouds. Kind of fun to talk about. Love to know what your favorite subject is. Comment below with what your favorite subject is. Grace says science. That's fantastic. Good to have you on board. Gym class. You know what? I love gym. I loved playing sports. I love playing basketball. I love playing baseball, football, all of them. Gym was a great release. So was recess and lunch. Those were a couple of my favorite times during the day. Hey, let's take a quick look around the nation today. And let's take a look at the radar. That's what we're looking at. And the radar shows us where there's precipitation. Anything green down here, that's rain. Anything blue up here, cold enough for snow, like it is in Fargo. We have flakes from time to time. Down here, near Houston, Texas, and Frisco, Texas, Dallas, Texas, we've got some rain that's got colors in it. Okay? How can rain and hail fall at the same time? James, that's an awesome question. Okay? Up in a cloud, we can have raindrops that are supercooled water droplets and ice cubes that are hailstones together, and when both of them get big enough to fall, or they get out of the updraft area, then they can both fall. So let's say we have a supercooled water droplet here that grows so big it starts falling back down through the updraft. Then that'll fall and it'll melt back into rain as it falls through the warm layer. If we have an ice chunk that's solid ice, it's an ice cube at 30 below, that thing can fall also at the same time that supercooled water droplet did. And they both fall down together. The supercooled water droplet warms and remains liquid. The hailstone may not have time to melt before it hits the ground. It likely will shrink. It likely will shrink from the size it is up in the cloud. That's a great question. Looking at today's radar, we see some interesting stuff going on down here near Texas. We got some reds on the radar screen. We got some yellows on the radar screen down there. Let's zoom in a little closer, shall we? Well, maybe first I'm looking at the temperatures down there. And we talked about we got to have areas where it's warm enough for hot pockets of air to start rising. New Orleans is 87. Look at Miami. Oh, goodness. 94 degrees. Are you kidding me? In Miami, Florida. We are 17 in Fargo. Okay. If you're watching from out of state, say hi. Tell me where you're watching from. I know we got the Papa in Georgia watching. That's good to have you on board. Or is it Alabama? I'm sorry. At any rate, it's 17 in Fargo today, and it's 60 degrees warmer in Dallas. So we got a lot more hot air at the ground to rise. Okay, that hot air rises, and it can form thunderstorms. And here we have thunderstorms that are by San Saba. Okay, I'll stop it from looping. And that thunderstorm was severe at one point. A severe thunderstorm can make big hail. Okay, so those thunderstorms have really strong updrafts that can make big hail. These thunderstorms down here by Tividale and just near San Antonio aren't quite as strong as this one up here. So the updrafts aren't strong enough to make the size hail that would make that storm a severe thunderstorm. Okay, so meteorologists watch the radar to see which storms might be capable of those strong updrafts. And if we go in a little bit closer, we can track the hail size with our radar software here, and just through Llano, Texas, and maybe just north of Marble Falls, maybe they had marble-sized hail. Okay, all right. So hail is fun. We've got a few minutes to talk about our experiment today, and let's talk a little bit about that. Also, Heather, good to have you on board. Hi, Michelle. Gavin asking is, what's the difference between hail and grapple or freezing rain? Good question. Gavin, rain and freezing rain. Rain is a liquid drop falling from the cloud. It's liquid. It's like what comes out of your water faucet. And it drops out of the cloud. And as it falls below the cloud where there was freezing temperatures, it falls down here toward the ground where the temperatures likely are above freezing on a thunderstorm day, like it is in Texas today in the 70s. So that liquid drop stays liquid all the way down to the ground, and what hits the ground is liquid water. That's rain. That's easy to forecast. And in our last class, we talked about the difference between freezing rain. Freezing rain is we take a snowflake out of the cloud. It melts as it falls through a slightly warmer layer. That temperature might be 34, 35 degrees, but it melts the snowflake into a liquid drop again. Now we have a liquid drop. But what happens if that liquid drop now falls down closer to the ground where the temperature is 17 like it is in Fargo today? So sometimes above the ground up here and below the cloud here, we can have a warm layer of air that's warmer than freezing, and that can melt snowflakes. And if it melts snowflakes into liquid drops and there's a freezing layer down by the ground, that can lead to freezing rain. And that's a liquid drop that freezes on impact. So it splats on your sidewalk and then freezes instantly. It splats on the windshield of your car and freezes instantly. So that's the difference between freezing rain. And the difference between hail and grapple, that's quite a bit of difference. Okay, grapple is like a snow pellet. A snow pellet. So that's like little tiny snowflakes that get glued together by a little bit of supercooled water. So they're a little crunchy when you crunch those snow pellets. They're not solid ice. Hail is just like an ice cube out of your freezer. So let's talk about that. I asked you to get a frozen pea, and if you have one, I want to talk to you about updrafts and thunderstorms. Hutch is going to use corn, good old trusty corn, because I ran out of peas, like I said. Okay? How much rising air do we need to support the weight of this piece of corn? Okay? If we get a corn-sized or a pea-sized piece of ice in the sky, the rising air has to be able to support the weight of that piece of pea or corn. And if I just drop it, gravity pulls it down to the ground. And that gravity is pulling down all the pea-sized pieces of hail out of the sky. But if we have an updraft supporting that piece of pea, so you can take a frozen pea, hold it right over your lips and mouth, and look up and blow straight up like an updraft would in a cloud, and see if you can support the weight of that frozen pea. So go ahead. Here's Hutch. I'm going to try to support the weight of this this piece of corn here. Whoa, okay? So I blew almost as hard as I could, and that piece of corn it flew up in the air and away. So I can blow out of my mouth fast enough to support a pea-sized piece of hail. That's still a pretty strong updraft though, and not a lot of days do we have updrafts that are strong enough to even support a pea-sized piece of hail. And that's why hail doesn't happen from every thunderstorm. Now, I brought a couple of other examples because we often compare the size of hail. So we might have a corn-sized piece of hail or a pea-sized piece of hail. We call that pea-sized hail. Today it's corn-sized hail. We can have marble-sized, but we got to be careful with comparing hailstones to marbles because marbles come in different size. You can have small marbles or bigger marbles. It's better to use coins. So is it a nickel-sized piece of hail like I showed in the pictures earlier? Is it a quarter-sized piece of hail or a silver dollar? They can grow bigger than that. And I don't know if you've ever seen golf ball-sized pieces of hail. Why don't you type in the comments when you have a second? What is the largest size piece of hail you have ever seen? Okay, and I'll start listing off some. Pea-sized hail happens an awful lot. We see that pretty frequently. Golf ball-sized hail doesn't happen very often. Okay, maybe once every few years here at Fargo at most. Okay, in 2008, we had a storm that made golf ball-sized hail and larger in Fargo, and it damaged a bunch of roofs. Here's a golf ball. Okay. Golf ball's pretty heavy. Dropped it on the desk there. It made a lot of noise. That golf ball has more weight than a piece of corn. So the updraft or the rising air that's required to support the weight of this golf ball is a lot. Okay? So the wind blowing straight up into the thunderstorm cloud to support this golf ball has to be blowing up there at least 60 miles per hour or so to support the weight of a golf ball. Do not hold this over your face and drop it and try to blow up and support the weight of it unless you're really brave or you want to possibly bruise your lips. Okay, and if you have braces, definitely don't do it. Okay, so we can have different size pieces of hail. Go ahead and comment with the size piece of. Sometimes piece of hail was as big as a volleyball. That's pretty big. Okay, we had golf ball size hail a few summers ago. Tennis ball sized hail, says Nathan. That's big hail. Carly says golf ball size. Golf ball size hail in the city of Fargo happened in 2008. It's been a while since we've seen golf ball size hail in Fargo. And I know we've been on the air and talked about storms around Fargo and around Grand Forks that have had much bigger hail. So I've got some examples that I pulled out of my garage. Once in a great while, probably once in our neck of the woods, maybe every 5 years or so, we'll see baseball-sized hail. Okay, that baseball is heavier than the piece of corn, and it's heavier than the golf ball. How much wind has to be blowing? How fast does the wind have to be blowing to blow this baseball up and keep it supported up in the cloud? And the answer is going to be close to 80 to 100 miles per hour. So you have to have the wind blowing straight up in the air, 100 miles per hour. I have never seen a hot air balloon, no matter how hot we make that air, I've never seen a hot air balloon rise at 100 miles per hour. So sometimes thunderstorms need help. We can't just have air that's drifting up like a hot air balloon that's going up and blowing up there at around 10 miles per hour, 20 miles per hour. There's got to be something else inside these thunderstorm systems that make the air blow up faster. Baseball size as a kid was camping. It was unbelievable. Teresa says, this is unbelievable hail. And as big as hailstones are and as high as they fall from the cloud level, these baseballs come down with massive force. They can actually puncture holes in people's roofs and land with ice in your living room, okay? They destroy all kinds of things, not just your car's windshield, not just your car's metal, but all kinds of things when we get baseball-sized hail. From time to time, this has happened in North Dakota, Rame, Golva, southwest North Dakota. When I was working out in the Bismarck area, we had numerous reports of softball size hail. Bowling ball sized hail would be ridiculously large, Nathan, and I've never seen that. We have had hail as large as 8¼ inches, and I think that's the record, and it happened in Nebraska. But even this, This is a softball, okay? Had it in the garage. Baseball, softball, a little different in diameter, and the softball, it's going to be heavier, okay? A softball-sized piece of ice is going to be even heavier. Then how fast does the updraft need to be, okay? I found an old softball, and this is a fun one. I think this is one we used to use in gym class. Okay, do you see the difference? This huge, ginormous softball here. So sometimes softballs, they have different sizes. So do some baseballs. So it's hard to compare hailstones to baseballs and softballs because some of them are different size. So sometimes it's just best to take your piece of hail and measure the widest part of it with a good old-fashioned ruler. And then you can tell how big the hailstones were. Hailstones happen in thunderstorms with really strong updrafts, and those really strong updrafts can support different sized pieces of ice. Sometimes from the same storm, you're going to get tiny little pea-sized hail for a while because they got up in the storm and flew out of the updraft to a different part of the storm and fell out over here. Okay? But sometimes the golf ball that's in there got stuck in that updraft zone, rising, sinking, rising, sinking, rising, sinking through the frozen layer of super cold water that we talked about, super cooled water. All of it's very interesting and all of it's very fun. And you guys, this has been a fun class. I have an announcement to make to you guys here today. We will announce what classes and the subjects that are happening for next week. So watch for that. We should have that by either the end of the day today or by tomorrow. And we want to give a shout out to teachers and students doing distance learning. A+2V here, I think is what we're calling this. Look, we love all you parents working with your kids to teach them, teachers working remotely to teach your students, and of course the kids who are just trying to learn a little bit of science today, okay? You guys, teachers, parents, and kids are recording messages to each other and giving shouts out to each other, and we want you to upload your recordings that you're passing back and forth to each other to our Valley News Live website. Go to the valleynewslive.com website and upload your shout out, okay, to your teachers or to your kids. Add a video giving an A+ to anyone working hard to keep up with education in these trying times. And that's kind of what Hutch's class is about too. It gives us something fun to talk about. So I hope you learned a little bit about hail. We'll have some more interesting topics. If you want to comment below with a subject you'd like me to cover with regards to weather, type it below. Thank you all for joining me today. I hope you had a wonderful time. I try to keep these to 30 minutes or less. If you do have any questions, I'll watch for a minute or two here and try to answer them as we go along. I tried to answer a few while we were going along as well. So wonderful to have you. Love the likes. I love your comments about what kinds of classes we should have. And make sure you share this or tag a friend down below in the comments section if you think they may enjoy the class. Until next time, next week on Tuesday and Thursday, I do plan to have more class then. So look for the subjects right here on the Valley News Live Facebook page or on my Facebook page. And I'd love for you to go ahead and go to Hutch VNL on Facebook, Hutch VNL, and give that page a like as well. Is it ever going to warm up? Oh my goodness, that's a wonderful question, Michelle. It sure seems chilly. This is Fargo today. Look at that. We've melted a lot of snow, and we melted it all once, and then we got another 5 to 9 inches of snow, and now that's almost melted again. So once we get that melted, yes, it will warm up. And I will just leave you with some golden sunshine news because it's always fun to have a half a glass of milk that's half full, not half empty. And here's the 7-day planner and the 7-day forecast. And it does show that tomorrow and Saturday look much better. Thank you guys for watching here. I'll leave you with the 7-day for a couple minutes. So yay for Friday. After today, a windy, blustery day with flakes. We're going to warm up in the 45 to 50 degree range Friday and Saturday here, and it's going to feel marvelous. Can hail be flung out of a tornado? I would say so. I think at the cloud level and inside the cloud, when a vortex or a spinning thing starts happening inside the cloud, It acts like a centrifuge. You know what a centrifuge is? In science class, when you take science, you'll learn about centrifuges. Okay, they can be used in the medical field to, say for instance, you take a vial of fluid and you spin it real fast, and then the solids in that fluid start going to the outside of the spinning motion. So you can, inside a cloud, you can imagine once we get a vortex of spinning air, that all of the rain and hail gets thrown out of that vortex. Okay, and it shows up on radar that we have this area where there's no reflectivity because all the rain and the hail has been thrown out of that part of the storm. And that's what we call a hook echo on our radar screen. So meteorologists watch for storms that make hook echoes, and we watch them extra carefully because they could have a spinning motion in them that's causing the rain and hail to be thrown out or vacating a certain area in the storm. Hey, Tim says from the Luther Family Forward Weather Station that they got from being a weather kid, it says it feels like 26 up there north of Valley City. That's an awesome report. Thank you, and I'm really glad you're making use of our sponsor's gift to you for being a weather kid. Share this with my grandson. Definitely do that. He is interested in becoming a meteorologist, Henry says. Yeah, absolutely. Share him these classes. We have all of these classes posted on our webpage. You can go to valleynewslive.com and click on the weather menu at the top. And right in the upper right-hand corner of the weather page, you're going to see a big button that says Hutch's Weather Class. Click on that, and all of the classes we've done, and they're all about a half hour long, are all listed right there. All right, last night, got some snow last night. It's already melted. That's good. 31 degrees in Moorhead, James. That's wonderful. Wonderfully cold. I'm ready for something warmer myself. So, all right, you all. Have a wonderful, wonderful rest of your week. Remember to check out and upload your videos, the A to V. We'd love to have those where you're giving shouts out between parents, teachers, and kids. Keep on learning. It's fun. Never stop learning, even when you're old like Hutch. Good to have you on board. Thanks so much. See you next week for Hutch's Weather Class.